Hey everyone. My name is Brian Egan. I'm formerly a software engineer, Android engineer, and web engineer at Zappos, which is a e-commerce company in the US. And then I moved over to Berlin a few years ago and was working for SoundCloud for about 4 years as well. And then about a year and a half, almost 2 years ago now, I guess, I just saw a blog post on Fuchsia, and they mentioned Flutter, and I was like, I'll just take a look at that. And I think I was, I'm not here to dig on Android. It's a great platform, but for me, I don't know, coming from web, I missed some things about the web, especially if you've used Flutter, like hot reload, just this ability to really see changes and to have really full control. And so I started working on Flutter stuff and was kind of still in that mindset of Android as well, of hey, I really like RxJava. I was used to those types of patterns. And on the web, we used a bit of RxJS as well. And so I was starting to think about how we could use sort of these stream-based or reactive patterns for Flutter apps. And so I started doing some stuff with RxDart and just started realizing that the Streams API was actually a bit limited. And so started working on RxDart a lot with another developer named Frank, who's based in Belgium. So this is sort of a talk about what I feel like I've learned kind of playing with different architectures. I've also done a lot of work on the Redux package, and I've kind of pulled scoped model out. I didn't write that, but I pulled it out of the Fuchsia code base and made it available. And I just started playing around with different architecture patterns. And so I still think that streams are actually a really cool way to model state and to work with architectures in Flutter, especially because streams come out of the box with Dart. And overall, I think there's sort of this sort of debate, I think, in the community of what's the best, the one true architecture for Flutter? And I actually think that's the wrong question to be asking. I actually think the right question to be asking is how can we apply the lessons we know that have stood the test of time? How can we apply those to Flutter, right? Whether you want to use Redux and you like that pattern, whether you want to streams, whether you want to use an MVP pattern if you're sort of an Android person, I think these are the types of things that we should be thinking about as far as how can we apply the lessons of the past. And so I was thinking about what are our actual goals. It's not what is the right library. Like I said, I think that's sort of the wrong question to be asking. And I think the right questions to be asking are how do we make layered architectures? How do we make our apps modular, right? So that if you've got a lot of different teams, they can all kind of work in their little part, their part of the code base, and not interfere with other people. So kind of coming from maybe slightly larger development teams, like at SoundCloud, we had up to 25 developers in the Android app. So you really need to have an architecture that supports teams working independently, and modularization is a big part of that. Another big part is testability, right? So I worked at an e-commerce company. If you add something to your cart and you get to your cart and it's not there, you're going to lose business, right? Or if you download a track on SoundCloud, you go on the plane, you hit offline mode, and it doesn't work, you're going to lose business. So I really think testability and the ability to test your architectures, whatever, like I said, whatever solution you end up liking, whether you like Redux or Streams, I think, like I said, testability is just a good thing to bake in. Because we're working with an object-oriented language, it has some functional features, but I think Dart is very much as an object-oriented language. We can still follow the solid principles, which again, I think are principles that have actually stood the test of time. And it has some really unique advantages for how it renders UI, but I don't think we should throw all of these lessons from the past out, actually. And of course, our architectures, they need to handle all the normal bits. They need to be able to talk to databases or web services. They need to react to user input, of course, and just do normal stuff. So if we kind of think about what Flutter brings out of the box. So I started with just what does Flutter offer? And you start with stateful widgets, right? And these are essentially, the stateful widget itself is almost like a shell. So it just takes in some properties. So in this case, it takes in a couple of constructor parameters. And really, it pretty much just gets out of the way after that and says, OK, create a state object, and the state object does everything interesting. So then you have your state class, which you implement. And in this case, I'm just going to focus on the counter example, because I actually think it's a pretty, it's kind of a simple example, but I think it has a lot of interesting little things kind of going on if you take a look at it. So for example, you might have your data model that you need and the data that you're planning on mutating. So in this case, it's just a counter, so it only has one piece of state. It's quite simple. And then you have your increment counter method, which will, of course, increment the counter when it's called. And then it also calls set state. And that will tell Flutter, hey, some state has changed, and I need you to rebuild this widget. Finally, you actually have the build method. And that's where you take the data that you're getting from the state class, like the properties that you pass in, and maybe the actual data that you've got in your state class, and you sort of turn that into a UI. So you've got your counter that you're rendering as a piece of text, and then you can use a button, and you can call the increment counter method when the button is tapped, right? So you could also start putting data logic in there. I think I see this kind of thing where, okay, now we can start making network calls, right? But I think you're going to quickly run into some challenges if you kind of go down this path. And so, like I said, I think testing is important. And so I wanted to say, look at Flutter, try building an app like this and see how does it work with testing. So what I was hoping I could do is just write a pure old Dart, like plain old Dart test, instantiate the state class, call the increment method on that state class, and then eventually say, okay, I expect the state to be at 1 now. The problem is that the state classes are tied to the Flutter framework. And so you actually need to use the tools that Flutter provides. And actually the fact that Flutter has these test widget utilities, it's amazing. It actually allows you to test your UIs in really nice ways. But for business logic or for data transformations, things like this, it starts to get more complex, right? So you need to pump the widget, so you need to build the widget in the test environment. Then you have to actually look through the widget tree and tap on the button. So this is already maybe starting to get a little bit crazy. Then you have to build the widget again. The way that the Flutter tester works is it won't automatically rebuild like it does when you're using an emulator or on your phone. And this gives you really fine-grained control in a test environment to make sure that you can tell Flutter, hey, now I need you to rebuild, and now I expect the state to be different. But it does require some mental overhead to remember that. And then you have to look through the widget tree and expect to find your value. So I think if you were thinking about this, maybe this is like not that great, but maybe it would work for a simple app. But if you could think about okay, you actually want to do some more interesting list transformations, starting to test that kind of stuff is going to be really difficult with this setting, this setup. So I think if we sort of look at our checklist, the things that I think are important, we can start to see that our app is it's not very well layered. In fact, I think you could say that we've got a lot of responsibilities in a single class in the state class. It's not very modular, or it could be considered modular in some ways, because you could still have your search team working on their search widgets and your product page people working on their product page widgets. So I'd give it like a half check mark for that, because you might say okay, it's pretty good, but maybe not there. It's interesting that you can test widgets like this. Actually, it's a really cool feature that you can test widgets like that, but it's maybe not the best for all types of logic. I think the test widgets function is amazing for testing widgets, but maybe not for testing business logic. And it definitely doesn't follow solid principles, right? So the first rule of solid is that one thing is the responsibility principle. But I think in the state class, you can see it does actually a number of things. It manages the state. It decides to draw in response to that state. And it actually even defines the data model within there in some ways. So you're starting to mix a lot of responsibilities into a single class. And you could do all the normal bits, right? You could talk to Firebase and talk to web services, like I said. But I think that the conclusion I came to when I was doing these experiments is that I think it's great for UIs and UI logic. State classes, it's perfect if you have a text editing controller like we were joking about earlier. That's sort of a UI state piece, right? And you can put those things in your stateful widgets and manage them there, and it makes sense. And it's amazing testing is built in Flutter, actually. So, for example, if you've worked with Android and you've worked with Roboelectric, you might know it's a lot harder to do on Android, for example. Web people with React, they have some cool tools, but at least on mobile, I can't speak for iOS, but and I guess no one in this room can. But yeah, it just felt like we were starting to mix a lot of stuff overall into one class. And testing complex scenarios, like I said, really becomes difficult if you were to test an interesting list transformation or something more complex. And it gets even messier when async code is involved. Because of the way the test widget function works, it actually does some interesting stuff to override the default async mechanisms that works really well for widget testing, but again, it can lead to some unexpected results where like you'll get an async error essentially when you're just making a normal HTTP call or something. Yeah, and so I think that all sort of leads to the fact that to me it started to look like a God class. Like I think if you were to think about this thing growing, you know, are there any Android developers who have seen some God activities in the room? Yeah, yeah. And this is what it made me nervous. I was like, oh gosh, is this like going to become sort of a God activity or a God widget, you know, God class? And so, you know, I thought let's really apply the principles we talked about. So let's apply layering. So in Android, I think, you know, we've probably all seen the architecture diagrams. And so this is, you know, you can start to layer your application by UI layer, by domain layer, and by your data layer. You know, in terms of you're looking at like having a view that talks to some sort of presenter, right? And then the presenter talks to like a use case or an interactor, which is going to actually talk to your, usually your data layer, which at least on Android is often represented as a repository pattern. And then your repository manages like, hey, do I have something in memory and I'll return that? Or should I go out to the network or go out to the database and try to fetch that information? And so in Flutter, we can actually pretty much use the exact same thing, right? And so these are your UI, your domain, and your data layer. In this case, though, we're just going to replace some names, actually, I think. And so one pattern you might have heard about that's presented by Google is called the Bloc pattern. And I actually think they should have just named it a presenter in some ways, because that's kind of what it is to me, actually. And your UI, your view layer is sort of represented by widgets. So how do these things communicate with one another? Well, in this case, you know, I think we can use streams to communicate. And so this sort of gets to the reactive or Rx or stream part of the talk. So what we can do is we can actually have widgets talk to the block. Like I said, I consider a block. We'll talk about exactly what a block is. You can kind of think about it as a presenter, in my opinion. And then the blocks can sort of talk to your use case and interactor layer, which might translate and do some other business rules, and then talk to your database layer or your data layer. And then, yeah, you can emit streams back. And so widgets can send data to the presenter, to the block via streams. And then when the block actually gets back from the data layer, from the domain layer, it can send that right back up to the view. And the view can consume the stream of data. So that might be kind of abstract. So let's take a look at how this works. So streams are actually built into Dart. And this is really cool. So you actually get language level support for streams. And that includes like async star functions, if you've taken a look at those. And those are actually kind of an interesting imperative way to write streams. The other cool thing about streams that's a real advantage, and actually this is the reason that Google chose to go with this technology, is because it actually works across platforms. So it's not limited to only Flutter. And so this is actually an interesting area where this type of layering gives you an immediate benefit. And so Google actually shares about 50 to 60% of their code with their Angular apps. So they have an Angular Dart app as well that backs up their AdWords product. And so this makes streams a really good case because there's nothing special. So for example, you might have tried, has anyone tried scoped model or value listeners or anything like that? So I actually really like them. They're really simple, but the problem is they are, once again, tied to the Flutter framework. It's a class called a listenable, which is just like in Flutter's framework. So you actually can't share them. And so I think this is one advantage or interesting advantage to streams. You'll also see streams just naturally if you're working with Dart in general. Like if you're using like the HTTP client, like you can get a streamed response from the HTTP client. Or the Firebase packages that the Flutter team provides, they emit streams of data. So it's sort of natural that you'll end up working with streams in any case. And you know, if you come from Rx world, like RxJava or RxJS, they're really analogous in many ways to observables. They're not the exact same, and even RxDart, it can't fully comply with the observable contract, and so we've even talked about renaming the library because we actually can't completely fulfill it. But you know, we're talking essentially about events over time. Yeah, so I think they are analogous in many ways. And so what we've done is streams themselves are great, but they're a little bit limited on functionality. So you're probably used to, if you're used to RxJava, you're used to being able to like merge streams in various ways. This is a super important pattern if you're going to be working with a sort of a stream-based pattern, is to be able to merge different types of streams together and combine them to create maybe a single or multiple outputs. The other thing is you might need really some I think kind of standard operators that I actually still think are kind of surprising that are missing from the Stream API, like flatmap, which allows you to, every time an event comes in, it allows you to convert that into a new type of stream, right? And so that's a really, I think, interesting and some key missing operators. So these are the types of things that we've just implemented essentially in RxDart instead. You also have subjects. So actually, you do have these things called stream controllers that I'll talk about in a second. But subjects sort of give you some extra power, like being able to replay the latest value that was emitted, or replay all values that have been emitted up to a certain buffer. So yeah, so streams, if you haven't worked with them as much, they're pretty simple in some ways. You can just listen to the stream of data. And so what you do is you provide various callback functions. And so when data comes through, you can run a function. When an error comes through, you can run a function. Or when the stream completes, you can run a function. And so this allows you to sort of hook in to the life cycle of the stream. And these are really just functions. So yeah, in this case, all we're doing is printing whenever an event comes through, or we're just printing an error. Obviously, this is super trivial, but yeah, overall, and then once it's done. So you have hooks into the main events that you would want to listen to. The other cool thing is you have a few different ways of creating streams. So you've got your normal stream constructors, like if you've got an iterable of some kind and you want to create a stream from that, you can totally do that. Or if you've got a future, which is a pretty standard thing, and you can convert that into a stream. And then RxDart brings in some more power, essentially. So you can like concatenate streams, or you can defer when a stream is created until later. And there's more of these. Now, I think another kind of cool one is the async star functions, actually. And I'm not sure, I don't know if like the Flutter or team really uses or talks about these as much, but I really like them. So what you can do is, say we've got a search UI, right? Which we'll demonstrate this in a second with a real app. And so you're going to get an event like a search. So you're going to have like a stream, for example, if your view is emitting streams of terms, search terms, as someone types in. And each time they do that, you want to actually go ahead and start showing a loading state. And then if the result is a success, then we'll want to show those results. Otherwise, we'll want to show an error. And so what you can do is you can actually mark your function as an async star function. And this means that you have to return a stream from this function. It's kind of like an async function. If you've used those, it says, OK, you're going to be returning a future now. And then what you can do is you can use this yield keyword, and you can say, OK, now that I'm going to start showing a loading state. And this is, I'm just loading, like showing strings, but you would probably want to show more interesting objects here. We'll take a look at that in a second. But yeah, just as an example, so OK, emit a loading state. And then we'll actually, oh, I didn't do that. So, but you can then wrap your network calls in a try catch. And then what you can do is you can say, OK, let's try to await the search from the API. And if that succeeds, we'll yield that result. But if there's an error, we'll go into the catch block and we can yield something else. So this is a really standard pattern where you don't want to like just throw up some random error to the user. You probably want to show like some sort of like, hey, that didn't work. You've hit the rate limit, or that's a bad deal. So this allows you to have like actually I think a pretty nice and a pretty imperative way of dealing with these types of things. And you can totally do this with RxDart as well. Actually, you can like do a start with loading state and then on error return if you're kind of familiar with the RxJava APIs. But I just think this is an interesting alternative and kind of nice for folks who might not be like as deep into Rx. And the final way is a stream controller. And this is to create streams. And so these sort of do two things. They're sort of inputs and outputs like in one sort of thing. So it provides a stream that you can listen to. And then it also provides a sync. And a sync allows you to add data. And then whatever's listening, when that data is added or when an error is added, it will be sent to the listeners. And if you're used to Rx, this is really analogous to like a publish subject. And in fact, publish subject in RxDart is a stream controller that just returns an observable rather than a normal stream. And that's just really like for convenience, essentially. So yeah, what's an event sync? As I said, it's just got three methods, add error, and close. and these will just be sent to your listeners. So when you add data to a controller, it'll be sent to the listener on the stream. Same thing with an error, and then when you close the stream, it'll basically trigger your onDone function. If you're used to Rx observers, it's really similar to like an observer.onNext, on error or on complete. So if you've used like subjects which implement the observer interface, then I think you can kind of see the analogy here. So this leads us to the block pattern, which is, like I said, this is a kind of terminology invented by Google, the AdWords team specifically at Google. And it essentially sort of has like some kind of strict rules around it that really help you with layering. And so they say that syncs are used for inputs from the stream, from the view layer. So when you're actually like on the view layer, if you want to send data to the block, you can use the sync and you can say, hey, I want to like add a term to the controller. Then you use streams for outputs from the block. And in this case, because the whole point of this is that they can share this code across platforms, the dependencies must be injectable, and they can't be platform specific. So you can think about, once again, our solid principles of relying on an interface rather than a concrete implementation, right? So you can kind of think about it in that way. And of course, because of that, you also shouldn't have any platform branching. Like, okay, if this is Angular Dart, then do this. Or if it's, if it's a Flutter app, do that. Or if it's a server app, do that. You should just be injecting the dependencies for the correct platform, essentially. And as I said, I kind of think about it as a fancy name for a presenter. Maybe just like a reactive presenter. I don't know which they call it a block. But yeah, I don't think it's too crazy if you kind of just have these like things in mind. And so yeah, what's a basic block, right? So we have a counter block, and this is to kind of relate to our initial example. And so what you could say is you could say, okay, the view needs to update and display the latest count every time. So we'll emit a stream of integers that the view layer can listen to and render whenever it changes. And then in order to send data to the block, we'll use syncs. So this sort of, hopefully you can see the syncs are for inputs to the block, and the streams are outputs from the block. And so in this case, it's just a sync of void, because we don't need to actually send any data with that. I guess we could make it a sync of int if you wanted to like allow the data or the view layer to say, okay, increment by 2 or increment by 4 or whatever. And then generally what you want to do is you want to be a good citizen, and you want to dispose of, or close, I'm sorry, your syncs when all is said and done. And so in this case, our increment sync will be closed. So the actual implementation of this thing, I just wanted to show this to like hopefully kind of make it super clear what the contract is. You wouldn't necessarily need to split it apart like this, but yeah. And so if you have an implementation then, I'm just going to use a publish subject, and as I said, a publish subject is basically just a stream controller, so don't worry about that, but essentially you can just think about it as a stream controller. And then what you can do is you can provide a sync, and so we actually don't want the view layer to get like the whole stream controller, so like they might do weird stuff like listen to the stream when you actually don't want them to listen to that particular stream. So essentially what you can do is you can just expose only the sync portion of the stream controller, because stream controller implements sync. And so you can just do that by using a getter or something similar, or within a factory constructor you could do it there. And then in this case we'll just provide a getter, and this will be the counter stream. And what we'll do here is we'll just listen to the subject, and every time it changes we'll just run this scan function. And scan is really just an accumulator. So if you've used fold or reduce on iterables in other languages, you can just think about scan as very similar to that. The nice thing about scan is that every time an event comes through, it will run the accumulator and then emit the result. And so you can kind of keep emitting results. So basically this is just like a fancy way to increment a counter and turn that into a stream. The cool thing is that you can, if we kind of go back to our challenge, our testing challenge, right? The nice thing is that streams actually have some really nice utilities out of the box. So we actually can write pure Dart tests in this case, right? So we're back to pure Dart. We're not using test widgets. So we should expect this particular stream to emit 3 items. And just for simplicity, I've just used like the stream.fromIterable. But what you can do is you can say, okay, I expect like my stream, in this case, like I said, we're just kind of creating one. And I expect it to emit 1, 2, 3, and then done. And so you actually have these, I think, fairly readable and fairly nice and fairly fluent APIs for testing streams. And of course, you can also test errors. So in this case, we'll create a stream with just an error in it. And you can say, OK, I expect it to emit error of a certain type. Or you could even, this is just like what's called a matcher in the test framework. And you could write your own matcher, like a predicate, like, oh, I expect the error to have this type of message in it, or something similar. So I think we're starting to look good, right? We're starting to use our principles, like I said. We're starting to inject abstract or interfaces rather than working with concrete implementations. But what about Flutter, actually? And so this is really where Flutter shines, I think, and where the fact that streams are a language level thing kind of come into play as well. So Flutter has this concept of a stream builder. And this is a function, or sorry, a widget, and it takes in a stream and also a builder function. So it's a stream builder. Yep. So yeah, in this case, we can pass the block.counter in as the stream, right? So this will be emitting 1, then 2, then 3. And the builder function will just take that value and render some sort of UI from it. So this is really nice. It's almost kind of like just a functional transformation of inputs to outputs. And in order to send data to the block, once again, we can just say, OK, give me the sync, and I'm going to add null. And I hope Dart gets rid of this. Like, I hope that if you say void, you still have to send a null event or something through, and it drives me a bit nuts. Like, I wish you could just say add. And so I've even resorted to not using syncs as inputs. I've resorted to using functions as inputs in some cases, but it violates the block rules. So I'll stick to block for now. But I actually think, I think what I usually do is I just cheat and I say block.increment, and then under the hood I'll add it with a null, so that the view layer doesn't have to worry about this sort of weird quirk, I think. So yeah, I think we've kind of come a long way, and we've made it. And so now I started to think, I think we're starting to adhere to those principles that are more important than, like I said, a particular implementation. Like I said, I don't like this, so I would just expose a function. But either way, we're starting to layer our technologies. We talked about that a bit. We actually have a much more modular setup in some ways, because not only are your actual widgets modular, but now you can actually even make your data packages and your domain packages more modular as well. We looked at testability, and I think you can see that this, or hopefully you can see that this is definitely a win for testability. You're no longer tied to testing with the Flutter framework. You can actually just do your own thing and use the regular Dart packages. We're also following solid principles, so we're splitting up the responsibilities so that we don't have one class that's responsible for too many things. Like I said, we're working with interfaces, not concrete implementations, and then you're injecting the correct implementation depending on the environment. And of course, this can handle all the normal bits. You can talk to databases, or handle user interaction, all that kind of stuff. Yeah, so I think this is actually kind of a cool pattern and kind of a cool way of thinking about these things that actually has a lot of benefits for testing and for maintenance, especially as your team grows in size. Yeah, so maybe to make this a little more concrete, I think I have a few minutes left, so I kind of wanted to show some actual code. Like, I can show you a counter, but that's it's a counter. So let's see here. Let's see if I can increase the font size a bit more. Can everyone see that pretty well? All right, cool. Yeah, so this is just an example that I've got. Oh gosh, no. Cool. So this is just an example we've got in the RxDart repo itself. And so this is a GitHub search app, right? And so, come on, internet, don't fail me. Demo gods, be with me. Uh-oh.
The emulator's network is down. Yeah. Emulator sometimes plays up, so there's the crossing there.
Restart the emulator. Oh, yeah, you're right. No. Almost made it. Almost. It almost happened. Just didn't happen this time. Yeah, I'll go with the iOS simulator and see if I get luckier. Yeah, right? Let's roll these dice. I'm going to open the emulator at the same time, just in case. And hopefully we'll be back. iPhone X. Let's do this, buddy. All right, my laptop will take off for a second. Yeah, Yeah, but essentially this is just a small search app that I've built just to test out this sort of pattern, and I was using this to test out a few different stream-based patterns. So have people worked with or heard of MVI for Android, for example? Originally kind of from web, yeah. And so I was playing around with okay, MVI, and like I said, you're just kind of shuffling deck chairs at that point to see what feels the best to you, or you think makes the most sense to you. But it's not a big deal either way. And so I think the block pattern is kind of nice as a way to do it. All right, let's see if we got this. All right, there we go. So yeah, you can type in, you can do your awesome hero transitions. As we type in more characters, it'll go back to loading and then come back. If you just type in some nonsense, it should show a no results sort of thing. Hopefully I can overload the GitHub search API real quick, and I think it doesn't take much, then you'll get an error here pretty soon. Come on, buddy. There it is. Rate limit exceeded, we did it. All right. So yeah, you can sort of see basically what we're doing is delivering different types of values. So rather than delivering integers, I'm delivering different types of data back. So so if we take a look at this, right? So we have our block here. I'll go ahead and get rid of this. And it's really got two input, or one input and one output, kind of similar to our counter. So we're taking in an on-text changed sync, and that will just, every time the user types in a new value, it will emit, the view layer will add data to this sync. And so yeah, we could see views, searching for usages. Oh no. Nope, not going to happen. All right, so, and then the output is just a state, type of state. And so I'm calling this search state. And so if you look at this, why don't you save it? Yeah, so you basically just, this is the type of class that just represents the different types of output you could have. This is also one area where, for those Android folks, I do miss sealed classes in Kotlin, because it would be really nice if I could just define these as a sealed class in Kotlin. But you can still do this kind of stuff with Dart. And so, yeah, you can emit a search loading, the search error, no term, oh yeah, which is just if you don't put a term in, then it'll try to give you a little help for a message. Otherwise, it'll either return populated results or an empty result. So that's where you can kind of see these different UI states represented. And so if we come back here, all we're doing is underneath the hood, we're creating a published subject of string. And we're just saying, OK, whenever the text changes and it's unique or distinct, and also for those people who are keen RxDart, RxJava users, this would actually be distinct until changed in RxJava, but distinct is actually implemented by the stream class itself this way, so we couldn't change it, unfortunately. So yeah, so we've got distinct unique as well. And then we just debounce it. So we don't want to, every time the user types in, we don't want to start making a search request. We want to wait a little bit of time, let the user chill out for a second before we hit our backend. You don't want to hit your backend just tons and tons of times, especially on larger apps or larger services. You're just going to be overfetching. Then what we do is we use the switch map operator, and that will basically, every time a new search comes in, it will discard the old results and start fetching anew. And then what are we doing, right? Well, we're just calling a search function that returns a stream. And guess what? It's an async star function. So if the term is empty, we'll just yield a search no term, and that's the end of it. Otherwise, we'll show the search loading, just like we talked about earlier. And then we'll try to fetch the results. And if they're empty, we'll return, hey, this is a search empty, so show a no results type of screen. Otherwise, if we did get results back, then we can return a populated screen with the results. And otherwise, if there was an error fetching this kind of thing, we show the error, which you saw the rate limited. I just assume it's rate limited because that was always the error I was getting from the GitHub API. It might be because something else happened, but yeah. So yeah, overall, then if you look at the view layer, let's see the search widget itself. Then, essentially all I'm doing is, where's my stream builder? Yeah. So then all this thing is doing is listening to the state, the block.state, which is returning these things. We start with some initial data of search no term so it can render the UI nicely. And then essentially what we do is we just say, okay, so if, show search intro, if like search is no term, or if we show an empty widget if the state is search empty. Once again, this is where I would like some more language level features to clean this up. Like I don't necessarily love the way this looks, but it's also, it works as well. And so then we just basically show and hide, fade in, fade out different screens depending on what's going on. And then, let's see here, where's my text at? So then on the text field, we basically just say, hey, every time the text changes, we'll just add data to that onTextChange stream controller, or in this case, subject. And so yeah, that's how sort of everything sort of flows through your app, and you can model your stuff really nicely in this way. And you can also, of course, test everything. So you can just jump in here, increase the font size. Oh gosh, there we go. So yeah, in here then you can see we've got like our tests. So you can, I've got a mock GitHub API. Oh yeah, I guess I didn't really show that as much, did I? Oh no. But yeah, in the search block, we're relying on like kind of an abstract GitHub API class. And then in the test, we're just creating a mock API using the Dart Mockito library. Sorry, just one sec. And so yeah, we just start with a mock GitHub API, and then we pass that over to the search block. And then we can just run our expectations, right? So we can just say, okay, the first thing that this will emit is no term, because we want the UI to show no term at first, to let the user know, hey, go ahead and type something in. And then, yeah, we've just got our normal test cases throughout here. So yeah, so we'll emit a loading state when the result, when the API call is successful, then we'll return the proper populated state. And so what we can do is we can just say, okay, use Mockito to return a populated search result. Then we'll just trigger an add event because this is just a stream, this is just a sink that we're adding data to, so you can just do that from your test. Yeah, and then we expect that the block will now emit an order, no term, then a loading state, and then a populated state. Or if the user didn't enter anything in, we expect it to emit no term, and then like say they type something in, then delete it, then we would expect it to emit no term as the initial state, and then another no term after that's over. Or no term loading empty. And so you can kind of see, I think, and these are just actually, these are basically just like constants that I've created just to make it easy to read. But I think, or at least for me, maybe if this is the first time you're seeing this kind of stuff, it might look a little crazy, but I don't know, I really like the sort of expressivity you get with these types of tests. And then, yeah, of course, you can just run them like normal. Hopefully they won't fail or anything. Come on. Oh yeah, this is one of the new things. Okay, yes, success. All right. So yeah, and so hopefully that sort of concludes the demonstration part. Yeah, of like how to sort of split these things up. The hopefully advantages you might see for the fact of layering, for the ability to test these things more easily, and the sort of ability to segregate your responsibilities into different things, right? So your UI layer is really responsible for taking the data it's given and just rendering a UI, et cetera. All right. So yeah, if you want to look at more examples, yeah, this example is up on the RxDart repo. I've also got a couple of different Bloc implementations and an MVI implementation on a repo I maintain called the Flutter architecture samples. This is just sort of a playground for trying out different architectures for Flutter. George actually wrote a library called MVI, or called sealed unions, and I just use that to try to model data that way. It's essentially, you know how I saw like the different like 6 like subclasses of search state? It's kind of a way to model those in a way. And it's got some pros and cons. I wish we had language level support for this kind of stuff actually. And then Philip Hracek, who's from the Dart Flutter team actually, he's got a couple, I think like a Bloc example on his library called State Experiments. And you can also see more Bloc talks. I can just share these slides afterwards, or if anyone wants to take photos real quick. Yeah, and that does it for me. So are there any questions?
Any questions? Hi, great talk. One of the things that I like a lot about Flutter is the way that it gives you inherited widget as a way to get access to dependencies that might be ancestors compared to where you are on the widget tree. But when I think of it in terms of the checklist that you were presenting, it kind of fails on the portability side of things, I guess, right? Because it's Flutter specific. So would you say, like, are there like maybe some alternatives, or what would be your take about getting access to those dependencies? Because also in the example you showed, you had the block being used to access the stream that is fed to the stream builder, but you still had to get that block from somewhere. And I would think inherited widget is a way to wire things up.
Yeah, I think that part is sort of platform dependent, right? So if you look at like Angular Dart, it's actually got a really specific way of injecting dependencies. It's got a DI mechanism, essentially, a dependency injection mechanism. So I would say use that for Angular. And for Flutter, I think it's totally valid to construct the block. You might want to construct the block still in a stateful widget so that you can dispose of it when you're done with it. Depending on the block, you can control the life cycle. So if it's like your app config and you want that to live throughout the life cycle of your app, maybe you don't worry. But I still think it's totally cool to use an inherited widget and to be able to pass things down the tree with that. I don't think that's a big deal at all, actually. I think that's still, I've seen a few different solutions for like service locator patterns or DI. And I don't know, it's funny, like after trying a few of those, I just come back to inherited widgets. Like they're scoped to part of the widget tree, they're built in. You can like, I don't know, I actually contributed at least to like the IntelliJ. You can like type in like INH, like inherited, and then hit like tab, and it'll pretty much fill it out for you, all the boilerplate. So I think you can create inherited widgets super quickly that pass that down. So I still think actually like how you pass dependencies from parent to children is still fine to do in the view layer for what that makes sense for it. So like I said, in Angular used its dependency injection. In Dart, in Flutter, yeah, go ahead and use inherited widget. Thank you. Cool. Yep.
Any other questions?
Oh yeah, there's one back there actually.
Thanks. I didn't quite follow the part where you talked about you were using subclasses to simulate sealed classes in Kotlin or enums, I guess, in other languages. I didn't follow in terms of the UI code how that kind of got wired up.
Okay.
I think you did show it, but it was quite quick.
Yeah, definitely. Sorry, I was probably moving too fast. So if we look at like the search state, jeez. So basically what we have is I should probably make this like an abstract class search state. And then we just essentially have different implementations of it. Have you worked with sealed classes in Kotlin then as well, or?
Yeah, so enums and Swift.
Yeah, exactly. And so I think you could think about like the search state as like the parent sealed class. And then each one of these search loading, search error, search no term could be considered an implementation or extending that sealed class. And that would be nice because then in the UI layer, you could use something like a when expression and guarantee that you're handling all of the cases properly. The way it works right now is you just have to sort of unit test or trust your developer to implement all of those cases, I would say.
Yeah. So I guess the part I didn't follow is how, given that the state was one of these subclasses, how that actually got wired up. Is there a widget that selects matching case or?
Yes, so maybe I didn't show that, you're right, enough. So if we look at this, all right, trying to fix this problem. Editor, code. All right, there we go. So in here, we've got the stream builder, and this thing is going to be consuming the stream of search state, essentially. And then in the builder function is where you take, so you get this thing called an async snapshot. And this will be an async snapshot of search state. And an async snapshot is just sort of a wrapper around whatever data the stream delivers. Because the stream could maybe have emitted nothing at that point. So it might have no data, or it might have an error, things like that. And so what we do is we just say, because I'm providing initial data, I'm generally not handling the no data case because I'm just assuming that some data will be coming through. And then what we do is I actually create a stack. And in this case, I just like literally layer all of the different kinds of, so like error, loading, these kinds of things, just one on top of each other. And what I do then is within that stack, I like layering these things on top of each other. So I just show the search intro screen if the type of state is search no term, basically. So that's how I toggle the visibility. And then under the hood in search intro, I just use a widget called an animated opacity widget. And it will say, OK, am I visible? If so, I want to be 1, so fully opaque, so showing. Otherwise, go ahead and animate this out of the screen. Yeah, and literally all of these just work in the exact same way. So empty widget, once again, it just has this visible flag. And if it's 1 or 0, or sorry, if it's true or false, it'll just animate the opacity between those values. Yeah, so does that help?
Yeah, thanks.
All right, perfect. Yep.
No one else? All right, well, we can actually do some general Flutter questions as well, questions and answers, if anyone's got any general Flutter-y type questions. No?
Hi, so I'm really new to Flutter. I'm a React Native developer, and I was just wondering, why would I move to Flutter over React Native? Is it the testability, or?
I mean, I think if React Native is working for you, keep using React Native. You know, I mean, I think Flutter has some interesting advantages over React Native, and React Native has some interesting advantages over Flutter. They're just technologies. I'd evaluate the technology for your project, right tool for the job type of thing. So for example, Flutter doesn't have very good map support right now. So if you have a project that really relies on maps, you know, maybe don't use it. If you have something with a lot of custom animations, for example, and custom views, I think Flutter might be a better alternative because sometimes with React Native, right, you have to even dive down to the native layer and implement a native iOS and a native Android view to really get the performance you need from those animations. Flutter, I think, will give you better performance for animations out of the box from what I've seen. So I think it's really a right tool for the job type of situation. Yeah.
Cool, thanks.
Yep.
Any other questions? Okay then.
Oh, we got one over here. Yeah.
Thanks.
In my case, coming from Xamarin, I've been using like some dependency injection or service locator, and yeah, I just found a pattern which is from Thomas Burchan, I think it's a German guy.
Get it?
Yeah. So I just been playing with that. Coming from Xamarin, it's a good approach, I think, for me. And I also think all depends on your of your background. How you say at the beginning, try to apply what you know in the project. Don't become crazy trying to learn Redux, Bloc pattern, MVP. I'm trying to reuse that experience. So what do you think about service locator and the idea to doesn't have one inheriting widget for everything? For each like B models.
Yeah. Yeah, I mean, I think I have some hesitance around something like service locator, and this is just my own personal thing. Because you know, I think if you're using like service locators within like methods of a class, so say you aren't defining any dependencies, or like say your constructor, in your constructor you somewhere you need a GitHub API client, right? Rather than providing it to the constructor, you might just have a method that calls up to a service locator to find it and to use it. I do think in some ways that might hide the dependencies your class has and might make it more difficult to extract that class or to do something with it. And also it might make your testing more difficult in certain cases because at least with with Git, the way I've seen it's implemented, a lot of times you'll export like a singleton of some sort, and that will mean that you have shared state between your tests. And Dart tests can run in parallel, and actually do by default. And so just for me, sometimes I do worry about things like that. But if it's totally working for you, you know, like Thomas loves it. He thinks it's like really good. It's really worked for him. Like, you know, go for it. You know, like I think we can have different priorities and different opinions about these things. And if it works for you, if you know you can use it for testing and stuff like that, that's totally cool.
Like for small apps, you don't have any problem. But I guess if you are trying to develop a business app, you need to follow some known pattern, and it's just playing around Flutter, learning, and that's it. Thank you.
Yeah, and I mean, in the end, I think they're really similar even, you know, like you could still use the service locator to inject constructor dependencies, and I think that's a totally valid practice as well. So yeah, I would say if it works for you, if it works your app, you can tell I'm not like a super dogmatic dude. Like use Redux, use Flutter, F React Native, like no, like no. I think if it's working well for your use case, it's technology, evaluate it, and yeah, if it solves your problem in a good way, that's cool.
Okay then. I believe we've got some time spare. So if there is any other questions, I'm sure we can answer them outside. I think there's some drinks going as well. I think the bar is still open.
Yeah.
And if you got your tokens, let's get a drink.
Yeah. Let's do it. Thank you.